Hello students, how are you all? So as I promised it to you, I am going to give you concept through questions that is exclusively in our subject environmental engineering. So these questions include GATE 1 mark, engineering service examination question, TSPSC, BPSC, state AEAEE, any state exam, SSC JE, it also include SSC JE. So it will be helpful to understand the concept in the form of the theory questions, especially the theory, because environmental engineering is a subject where you get more and more theory questions and you are confusing a lot. So as I taught environmental engineering for more than 200 batches, so I know what to study and what not to study in environmental, and I know which state and which model of questions, which exam and which kind of theory questions it is going to show. So that with my expertise, I am preparing some questions for you, exclusively for you guys, because our motto is to make you more and more succeed in your upcoming examinations. So that will help you a lot to crack your dreams of government job, GATE and ESE top rank, and whatever it may be. So always we are ready to provide whatever the timely need as per your exam requirement. So day by day, every day, one video we are going to release before our exam commences, and we are here to support you at any time. So make your friends to subscribe our YouTube channel. Make your friends to join our Telegram channel, KPSR Students, so that they can get the links regularly, they can understand the concepts regularly, they can follow the KPSR regularly. So we are going to start with the first chapter, population forecasting. So you know that you are not going to get more and more questions on population forecasting anywhere, but still I tried to get the best questions for you, most expected questions for your examination. So we'll go ahead with the first question. The population of a town in 3 consecutive decades, 1 lakh, 1.1 lakh, 1.2 lakhs respectively. The population of this town in the 4th consecutive decade according to geometric method. So first you learn according to geometric method. It is clearly mentioned as per geometric method. Future population is equal to latest known population into 1 plus r by 100 whole power m. So as per the given data, so please ensure that as per the given data, you can write P1, P2, P3. So what is P1? 1 lakh, 1.1 lakh, 1.2 lakh. 1 lakh, 1.1 lakh, 1.2 lakh. Now, difference, X values you can take. 0.1 lakh, 0.2 lakh. Then you get R values. You know how to get R value? R is equal to X upon P into 100. So how can you take X upon P? So R is nothing but rate of increase percentage. So this is X1, this is X2. So you can get R1, X1 by P1 into 100. R1 X1 by P1 into 100. This is R1. R2 X2 upon P2 into 100. 0.2 upon 1.1 into 100. So which is 9.09%. R1 10%, R2 9.09%. So what you are getting R, geometric rate constant. Geometric rate constant formula, do you know it now? R1 into R2 whole power 1 by n. How many n values? R1, R2, two values. So you can solve this. 10 into 9.09 whole power 1 by 2. 10 into 9.09 whole power 1 by 2. Two n values are there. R1, R2. Two n values are there. So you have 9.534. So first you are solving to get R1, R2 by taking x1 by p1 into 100, x2 by p2 into 100. Then R1, R2 whole power 1 by 2, you are getting R value 9.534. Please substitute in the formula. Substitute over here. Population for how many decades? Please check it out. Population for how many decades? Consecutive decades means one decade, next one decade. Consecutive decade means next one decade. So take it. Population for the fourth decade is equal to population in the third decade 1.2 into 1 plus R value how much you got? 9.534 upon 100 whole power 1. Please check this. 9.534. Then 1.2 into 1 plus 9.534 upon 100 whole power n. So calculate it what you are getting. After getting this, you are getting 1.3144 lakhs. So it is option B. So nearby 1.3144 is nearby 1.33 lakhs. 1.3144 is 1.33 lakhs. So this is the option. Chalo. Now, the population of a town in 3 consecutive decades. Population of a town in 3 consecutive decades, 5,000, 7,000, 8,400 respectively. The population of the town in 4th consecutive year. Okay. Year or decade, same. Consecutive, they are talking about consecutive. So you can go by population of the town in 4th. So n is equal to 1 number of consecutive decades or years. N is equal to 1. 5,000, 7,000, 8,400. Please take P1, P2, P3. 5,000, 7,000, 8,400. So now calculate x values. 2,000, 7,000 minus 5,000. X is nothing but change in population. 7,000 minus 5,000, 2,000. 8,400 minus 7,000, 1,400. Now R values. X1 2,000, P1 5,000. 2,000 by 5,000 into 100. 2,000 by 5,000 into 100. 40%. Now X2 1,400. X2 1,400 and P2 7,000. P2 7,000 into 100. So what you are getting? 1,400 by 7,000 into 100. What you are getting? 20%. 20%, 20%. Now R is equal to again 40 into 20 whole power 1 by 2. R1 into R2 whole power 1 by 2 because two R values are there. R1 40, R2 20. 40 into 20 whole power 1 by 2. Now 40 into 20 whole power 1 by 2, what you are getting? Please calculate the value. Please do the value. 40 into 20 whole power 1 by 2. Some value you are getting this here. So now future population is equal to after solving. 8,400, 1 plus 40 into 20, 800, root 800 by 100 whole power 1. 1 by 2 is nothing but this is root 800. Root 800. So root 800 taken there directly R value whole power 1. So what you are getting? So what you are getting after substituting? Please tell me answer. Kya aa raha hai babu? Answer. What you are getting? 10,775.8. So you take 10,776. Which answer? Which is equal to 10,776 near to 10,920. Nearby value. So option C is correct. Chalo, we'll move on. Completed. 10,776 near to 10,920. We'll go ahead then. Next question. Suitable method of forecasting population for young and rapidly growing cities. If you take arithmetic, it is for old and settled cities. You take arithmetic, it is for old and settled cities. Young and rapidly growing is geometrical method. Geometrical, exponential, logarithmic, all are same. Geometrical, exponential, logarithmic, all methods are same. Young and rapidly developing cities. Option B, geometrical method. It may be old city or it may be new city. You don't know, you don't have clarity. Then go with incremental increase method. About the city, old or new, developing, old, you don't know, go with incremental increase, best suitable. So the formula Pn is equal to P into 1 plus R by 100 whole power n. Just now we solved the question regarding this. E is used for forecasting. Geometrical rate, if it is arithmetic, Pn is equal to P plus n into x bar in arithmetic. This is geometrical. P plus 1 plus R by 100 whole power n. That is geometrical. Incremental. Incremental, how you can write? Pn is equal to P plus n into x bar plus n into n plus 1 by 2 into y bar. Pn is equal to P plus n into x bar plus n into n plus 1 by 2 into y bar, incremental increase. In case of incremental increase method, for forecasting population, the incremental increase is always constant, always positive, always negative, maybe positive or negative. Because incremental increase value, sometimes y bar is positive, sometimes y bar is negative. That depends upon the scenario of the city. It varies depending upon the city condition. So it may be positive or it may be negative. Highest population value is provided by which method? Which method? You know it now. Highest. So we can take first geometrical rate method. Geometrical increase is first, followed by mostly incremental increase. Incremental increase, then arithmetic increase. Maybe sometimes it may vary if incremental increase is less, but always highest increase is by geometrical increase, no doubt about it. Then next question. So see, easy questions, if you know the concepts very well, if you know about population forecasting well, know the formula, arithmetic rate, geometrical rate, incremental rate, always the questions are related to it. The suitable method of forecasting for population. So already we have written about it now. Old and settled city is best. Arithmetic increase. Young city is geometrical. Old or new is incremental. Which of the following method is considered for any city weather? Please check this. Just now I told for old or new, no clarity. You want to do forecasting. So if it is old, arithmetic. If it is young and developing, geometric. It's not an young and developing, it may be new, it may be old. Then what you can go? No clarity, incremental increase. See. As compared to geometrical increase method, arithmetic increase method gives. Arithmetic increase method gives as compared to geometrical increase lesser value, because arithmetic increases by arithmetic mean you are taking x bar. Geometrical increases by geometric mean r you are deriving from geometric mean. Always geometric mean is greater than arithmetic mean, no doubt, so that it is a lesser value. The population figures in a growing town: 40,000, 46, 53, 58. Values given. Predicted population in 2010. 2010. By which method? Arithmetic regression. Please understand whether they have given arithmetic increase, arithmetic regression, arithmetic growth rate, all are same. So first calculate x. X is nothing but change in population, dp. 46 minus 40. dp is nothing but p2 minus p1. p2, 46. So you put like this: p1, p2, p3, p4. p2 is 46, p1 is 40, 6,000. p3 minus p2, 53 minus 46, 7,000. p4 minus p3, 58 minus 53, 5,000. So x is 6,000, 7,000, 5,000. X bar. Arithmetic rate constant x bar. 6,000, 7,000, 5,000. Arithmetic rate constant. How many values are there? Arithmetic mean na 6,000, 7,000, 5,000, 3 values are there. Arithmetic mean you are getting 6,000. So you need next decade population, immediate decade. So population for 5th decade immediately. Last decade population P0. This is P0. 58,000. So you have to take P plus N into X bar. P is 58,000. Immediate decade, so N is 1. X bar 6,000. 64,000. Because N number of decades, next decade only required N is equal to 1. X bar calculated 6,000. Population latest value 58,000. Answer is 64. What is 64,000? 64,000 is option C. Option C. 64,000. The population of a city in the year 2000 was 82,300. In the year 2000, 82,300. Average percentage of increase of population per decade, 35%. So what is this average percentage? R, 35%. The population of city in the year 2020 estimated using geometrical increase. Population of the city in the year 2020 estimated using geometrical increase. Pn is equal to P into 1 plus R by 100 whole power N. P is 82,300 into 1 plus 35 by 100. 2000 is given, 2020 required. 2000 is given, 2020 required. 2020 minus 2000, 20 years. So 2 decades, 2 decades. So calculate it. 82,300 into 1 plus 35 by 100 whole power 2. Whole power 2. What you are getting? Please check it out. What you are getting? 1,50,000. So option C. 1,50,000 option C. On which of the following factor does the population growth in a town normally depends? So population growth surely depend on birth rate and death rate, no doubt. Population growth depends upon migration. Migration is relocation. One town to other town, village to city, city to other city, city to country, other country. That migration rate will affect. Probabilistic growth, logistic growth is our technique, mathematical techniques or graphical techniques what we are deriving. It does not depending upon the techniques. So 1 and 2 option B. 1 and 2 option B. So these are the questions I think we are having done. We don't have now more questions. So these are the questions we are having from population forecasting. Around 12 questions we have solved, and I assure you most of questions for your state exam, 1 mark in GATE or any examination, these are the models most regularly coming. And GATE 2 marks are different level, we solved in the plus course those questions. Only this is related to GATE 1 mark, state exam, SSC JE and theory questions. Okay, so tomorrow we are going ahead with water demand topic. So I hope you enjoyed the session. Like, share and subscribe the channel and spread. Please share the video with your friends and make your friends to join our Telegram channel KPSR students so that they can get the regular updates regarding classes and new initiatives. And make your friends to join Unacademy to use our code KP Civil and let them crack their dreams. Let's crack it.